Welcome to Coast CCNA Learning, your complete guide to conquering the Cisco Certified Network Associate exam. In this video, we're going to explore CCNA Topic 1.5, Compare TCP and UDP. Have you ever wondered how your data actually gets from one app on your device to the right app on someone else's? That's the job of the transport layer in networking. Think about a typical study session. You've got multiple browser tabs open for research. Maybe you're streaming music or a video in the background, and you're also playing an online game or chatting with classmates. All of those applications are generating traffic at the same time. The transport layer makes sure that each stream of data, whether it's a song, a video, or a chess move, is delivered to the right application in the right format without crossing over into the others. The transport layer provides end-to-end communication between applications. It takes large chunks of data from software, breaks them into manageable segments, and ensures those segments are delivered to the correct application on the other side. It performs functions like segmentation, reassembly, multiplexing, and error detection. Some transport protocols add features like reliability and flow control, while others are designed for speed and efficiency. For the CCNA exam, the two transport protocols you need to know inside and out are TCP and UDP. Let's compare them. TCP, or Transmission Control Protocol, is one of the most widely used transport protocols on the Internet. TCP is connection-oriented, which means it establishes a logical session between two endpoints before transmitting data. It is essentially a two-way conversation, where both sides keep track of what has been sent and received. To start this session, TCP uses a three-way handshake. The client sends a synchronized message to initiate communication, the server replies with synchronize acknowledge to confirm it is available, and the client responds with an acknowledge to complete the connection. At this point, both sides are ready and agree on the parameters of the session. When the session ends, TCP uses a four-step termination process with the finish flag, ensuring both sides agree the communication is complete. During the session, TCP guarantees reliable delivery. Each piece of data is assigned a sequence number, and the receiver uses an acknowledgement number to confirm which segments have been successfully received. This ensures segments are reassembled in the correct order, and that any missing or duplicate data can be detected. If a segment is lost, TCP retransmits it. TCP also uses flow control to prevent the sender from overwhelming the network or the receiving device. One of the main tools for this is the window size field in the segment header, which limits how much unacknowledged data can be in transit at a time. These features make TCP ideal for applications where accuracy, completeness, and order matter more than raw speed. Think of it as ensuring your assignment uploads to the cloud without errors, your banking transactions are processed correctly, or your email and chat messages arrive intact and in order. Typical use cases include web browsing, email, file transfers, and financial transactions. Anywhere reliability is critical. UDP, or User Datagram Protocol, takes a very different approach than TCP. UDP is connectionless, which means it does not establish a session or handshake before sending data. Instead, UDP immediately sends datagrams directly to the destination. There's no acknowledgement, no retransmissions, and no guarantee that the datagrams will arrive in order, if they arrive at all. UDP includes a checksum, but its role is very simple. It detects errors in the datagram. Unlike TCP, UDP does not retransmit or request corrections. If a datagram fails the checksum, it's simply discarded. Because of this, UDP is considered unreliable, but it is very fast and lightweight. A common misconception is that UDP is worse than TCP. In reality, it is optimized for speed and efficiency, and many applications handle any necessary reliability at the application level. UDP is commonly used in situations where low latency is more important than guaranteed delivery, such as DNS lookups, voice or video calls, live streaming, and online gaming. In these cases, it's often preferable to lose a few datagrams rather than introduce delays caused by retransmissions. Think of UDP as a one-way, speed-focused session. It delivers data quickly, without the guarantees of a two-way conversation like TCP. Here's a CCNA practice question on transport layer protocols. What differentiates the TCP and UDP protocols? Option A, TCP tracks segments being transmitted or received by assigning segment numbers. UDP adjusts data flow according to network conditions. The first part is true. Technically, it uses sequence numbers, not segment numbers, but saying that TCP tracks segments is accurate. But UDP does not adjust data flow. It's connectionless with no built-in flow control, so A is incorrect. Option B, TCP establishes a connection with the device on the other end before transferring, and UDP transfers without establishing a connection. This matches the definition perfectly. TCP is connection-oriented with a three-way handshake, while UDP just sends datagrams without setting up a session. This looks correct. Option C, TCP sends data at a constant rate with error checking on upper protocol layers, and UDP provides error checking and sequencing. That's reversed. TCP handles error checking and sequencing, not UDP. And TCP doesn't send at a constant rate, it adapts with flow and congestion control, so C is wrong. Option D, TCP immediately transmits data without waiting for a handshake. We can stop right there, because TCP always uses a handshake. Option D can be eliminated. That leaves option B as the correct answer. Let's review what we have learned. The transport layer is responsible for end-to-end communication between applications. It segments data, reassembles it at the destination, and directs it to the correct application using mechanisms like ports. It also provides optional services such as reliability, ordering, and flow control. TCP is connection-oriented and reliable. It establishes a session with a three-way handshake, uses sequence numbers and acknowledgments to ensure data is delivered in order, and implements flow control via window size to prevent overwhelming the receiver. TCP is ideal for applications where accuracy and completeness matter, like web browsing, email, and file transfers. UDP is connectionless and unreliable. It sends datagrams directly to the destination without establishing a session, acknowledging delivery, or retransmitting lost data. UDP is fast and lightweight, making it ideal for applications where low latency is more important than guaranteed delivery, such as streaming, voice and video calls, DNS, and online gaming. UDP also includes a checksum to detect errors, but it does not recover from them. In short, TCP is reliable, ordered, and connection-oriented, while UDP is fast, connectionless, and efficient with minimal overhead. The choice between them depends on the trade-off between speed and reliability. Now that you've explored and compared TCP and UDP, you're ready to dive deeper into the network layer. In the next video, we'll cover IPv4, addressing and subnetting, an essential skill for every CCNA candidate. Make sure you're ready, because understanding IP addressing is the foundation for all network routing and communication. If you found this helpful, click that subscribe button and stay tuned as we continue the CCNA exam prep series. Your network career starts here.